Hello friends, today I will be explaining you about our first coding pattern, which is sliding window pattern. So let's deep dive into this. And many times we found questions around this pattern only. So let's deep dive and let's understand how to solve the questions related to sliding window. I am just taking an array. Okay, so this is my array. So let's suppose some numbers are there. 2, 1, 5 is there, 1 is there, and 3 is there, 2 is there, and again 1 is there. Okay, so this is an array, and interviewer will be giving us the problem, and he'll be asking us to find the maximum subarray having size k. K here means we can include maximum k elements. Okay, so k can be any variable. So for example, if if k is 3, then we can include only 3 elements in our subarray. Okay, so if the size of k is 3, then we can include these 3 elements. So the sum of these 3 elements is 5 plus 1 plus 2 8. Okay, or we can include these 3 elements. Okay, the sum of these elements is 8, so, and the sum of these 3 elements is 6. Okay, likewise if we go, then sum of these 3 elements is 5 plus 1 6 plus 3 9. Okay, and the sum of these 3 elements is 3 plus 2 5 plus 1 6. Okay, and likewise this 3 2 1. Okay, 3 plus 2 and again 6. Okay, here also 6. Okay, so as you can see, the maximum sum is 9 over here, right? And since the value of k was 3, so we can include maximum 3 elements, and in this array, so if we include these 3 elements 5 1 3, then the sum will be 9. So this is our maximum sum. So we have to write code for this. Okay, and we have to find the maximum sum. Okay, so let's see how we can do this. I'm just creating this, just putting line over this. Okay, and now we have multiple options to solve this problem. Either we can use two for loops. Okay, I'm just removing this as of now. Okay, so we can use two for loops. The first for loop will will start from 0, and j is equal to I plus 2. Okay, so j less than equal to I plus 2. Okay, so what will happen is, since we have to include only 3 elements, our k is 3. Okay, so I'm just writing here k is equal to 3. Okay, so what we can do is, we can take two loops. The first loop with I starting from 0, and j also starting from I. So let me write in this way. Okay, so j will start from I, and j less than equal to I plus 2. And I will start from 0, and I less than length minus 1. Okay, so I less than equal to length minus 2 basically. So why we have included 2, why we are doing length minus 2? Because we know that we can include 3 elements. We have to include 3 elements. So in this case, if we include last 3 elements 3 2 1, then we don't have any option to include these two elements only. Okay, we have to include the three elements at least. Okay, that is why we can say that we can take I less than equal to length minus 2. Okay, so this is one way to solve this problem. Okay, let's take another example. I'm just okay, so this is our array. Okay, so I'm just going to take another example. Okay, so not example, basically I am going to take another approach. So I will tell you how you can solve these kind of questions. Okay, so this was our first way to solve this type of questions. Okay, the second way is sliding window. Okay, so let me select these first, and let me just move these over here. Okay, so this is our first way to solve this problem. Now coming to second way. Okay, so this is a sliding window pattern. So the you can identify you can identify whether we can apply sliding window pattern or not. So there is a way to find out that. Okay, so that ways, if you have to find elements, if you have to find sub array, okay, and that should be contiguous. Okay, so if you have to find contiguous sub array, okay, if you have to find, I'm just repeating, if you have to find contiguous sub array, okay, I'm just writing it over here, contiguous sub array, okay, then you can use sliding window pattern. Sliding window. Okay, so what that mean is, since we have to find a sub array in this question with the size k, and the sum should be maximum. Okay, so what we can do is we can include these three elements. Okay, or we can include these three elements, or we can include these three elements. Okay, so you can see that we are including maximum three elements since our k was 3. Okay, so in this case, as you can see, we have to find a contiguous subarray. There is no gap. Okay, so 215, it's a contiguous subarray. 513, it's a contiguous subarray. 151, it's also a contiguous subarray. If you have to take last three numbers, so 321, then also it's a contiguous subarray. Okay, so whenever you have to find any subarray, or I would say any contiguous subarray, then you can use sliding window pattern. Okay, as in this example, you can easily use, as you can see, we have to find contiguous subarray, so we can use sliding window pattern. So let's see what sliding window pattern says. Okay, okay, so what we can do is, in this case, we can slide our window. Okay, how we can slide our window, let's see. Okay, so let's see how we can slide our window. Okay, okay, now let's see how we can slide our window. Okay, so what we can do is we can take first three elements. Okay, okay, now let's deep dive into this and let's see how we can use sliding window pattern and what sliding window pattern is. Okay, so let's suppose this is our array. Okay, and we have to find maximum sum with sub array size 3. Okay, we can include maximum 3 elements. So in this case, what we can do is we can include first 3 elements. So in this case, what we can do is we can include first 3 elements. So in this case, what we can do is we can include first 3 elements. We can include first 3 elements. Okay, not till here. We can sum these three elements. Okay, and so what we will be doing is this window, as the name suggests, this is a sliding window. Okay, so what sliding window means, so you have included these three elements. Okay, so whenever you will move this window, okay, you will be leaving the other element. Okay, so you will be leaving this element. Okay, so whenever you will be, sorry, so what does sliding window means? So this is a window that we have taken 215. Okay, so whenever you will be moving this window, what you will be doing is you will be leaving behind 2 and including 1. Okay, so what you will do is you will leave 2 and include 1 in this window. Okay, so that is to say, if I sum these three numbers, okay, 2 plus 1 plus 5, okay, the sum is 8. Okay, the sum is 8. Okay, now we will move our window. Okay, we will move our window. So which means what we will do is we are leaving 2, we are leaving this element, okay, and including this element. Okay, so which means what we will be doing is we will be doing 6 minus 8 minus 2 is equal to 6. We have left this element and we have included 1. Okay, so our new sum is equal to 7. Okay, likewise if you will include, if you will so this was our window. Okay, if you will move this window further, okay, then what you have to do is you have to include 3 and leave 1. Okay, so you have to leave include 3 and leave 1, so which means 7 minus 1 is equal to 6, and you have to include 3 is equal to 9. Okay, so this is how sliding window technique works. Okay, so you are leaving behind something and you are including something, and you can see that it's a contiguous subarray. Okay, we are fulfilling our condition and we are including three elements at a time, and we are just excluding the element, the previous element, whenever we are sliding our window, and we are including our next element. Okay, this is how we are how this is how we can achieve this. Okay, so in this case the complexity of this algorithm will be, so the complexity of this algorithm will be O of n. Let's see how. Okay, so I'm just removing all this. I hope you have understood when we can use sliding window and where we should use sliding window. Okay, so in this case, since the loop was running for two times, one, this was the first loop and inside the second loop was there, so in this case the complexity of O n square. But in this case what we have done is we know that we can include first three elements. Okay, then what if means we in this case what we have to do is we have to include first three elements, then we know that we have to leave first element and include the next element. Okay, so we can run our loop. Okay, so we can run our loop from 0. Let's take this variable as I. Okay, so let's take this variable as I is equal to 0 to array dot length, just so in this case what we have to do is how our loop will run. Our loop will run from 0. Let's suppose I is equal to 0. Okay, let's suppose I is equal to 0. I will run till less than length. Okay, I will run till less than length, and what we will be doing is we will be maintaining a counter. Okay, counter. Okay, so if counter is 3, okay, until the counter is 3, we have to include the elements. Okay, since we are starting from 0, so the we can assume that the counter is 1 initially. Okay, so we have to include 2. Okay, now the counter is 1, so let me do like this. I have initialized counter with 0, and when I will include 2, I will initialize this counter with 1. I will increment this counter. Okay, and when I will include 1 also, then what I will do is I will increment this counter, so the counter value will be 2 in this case. Okay, and when I will include 5 as well in this. Okay, so in this case what I will do is I will increment the counter. Okay, so now the counter is 3. When we have achieved this, okay, so when our counter is 3, then what we have to do is, okay, then what we have to do is we have to take another variable which is max. Okay, which should be initialized with, let's suppose, -1. Okay, -1. If the counter is 3, okay, then what we will do is we will do math.max. Okay, so the max from max comma whatever the sum is, let's take this into sum. Okay, math comma sum, max comma sum. Okay, by this way we will be getting max value. Okay, so in this case for the first 3 elements, the max will be the sum of first 3 elements 2 1 5. Okay, and now when our window will move further, okay, when our window will move one step ahead, then what we have to do is we just have to decrement the sum decrement the sum. Okay, sum was here is equal to 8. Okay, decrement the sum and with the 0th index and increment it with second index. Okay, third index, sorry. So what we have to do is we have to subtract the 0th index, whatever is at a 0th index, from the sum. So in this case 8 minus 2. Okay, and include plus 1. Okay, so the sum will be 7. Okay, so we will keep track of maximum. So in this case we will be comparing max, which is 8 in our case, and with this value max comma sum. Okay, so 7 is less than 8, so our max is 8 as of now. Okay, and we will move further, so we will leave 1 as well, and we will include 3 in this, so it will be like 7 minus 1 plus 3. Okay, so sum is 9. So in this case you can see 9 is the maximum value from this array. Okay, so this is how we can solve this. Okay, so I hope you have understood the concept behind sliding window, and in next video I'll be telling you how you can solve any problem in which you have to find the contiguous subarray. Okay, so and how sliding window pattern can fit into that, and how can we solve the problem. of sliding window pattern. Okay, so in next, please do watch my next video, because I'll be telling you one technique by which you can solve any sliding window problem. You just have to apply that technique, and you just have to fit your variables into that, and everything will be done for you. Okay, so that's it for today. So I will see you tomorrow. If you like my videos, then please do share, subscribe my channel, and share the videos with your friends also. Thank you. Thanks a lot.